Japan, a nation known for its affinity towards cultural preservation and a steady rise in technological advancement, has surprised the world with its sudden development of one of the world's biggest sixth-generation stealth fighter jets called the Mitsubishi or Godzilla FX. How does this jet change the future of aerial combat? Could this cutting-edge technology trigger an arms race in Asia and globally? Join us as we discuss Japan's aerial beast, the Godzilla FX, and its impact on modern warfare. The debilitating effects of World War II on Japan cannot be overstated, especially with the atomic bombings of main cities like Nagasaki and Hiroshima in August 1945. The bombing played a major role in the surrender of the Japanese Axis in the Second World War. After these bombings, Japan did not remain the same, which isn't much of a surprise since its populace was vastly depleted and its economy was wiped out. After the war, the country signed a peace treaty with the United States that forced the United States military to occupy Japan. In fact, Article 9 of the Japanese Constitution ensures that Japan cannot build an army or maintain military forces for offensive purposes, which essentially prohibits them from using war as a way to maintain order or implement policies. Hence, sudden reports of creating a cutting-edge fighter jet that could impact the future of modern aerial combat seemed completely out of pocket, as no one saw it coming from a pacifist country. Some believe that the growing threat in Asia might have triggered their sudden decision to improve their military defenses. The Mitsubishi FX was developed by the Japan Air Self-Defense, becoming the first ever domestically developed stealth fighter jet in Japan. The jet is primed to replace the Mitsubishi F2 by the mid-2030s. However, the burgeoning question remains: how did Japan suddenly come up with an idea for the FX, since Japan's effort to purchase the Lockheed F-22 fighter jet had been frustrated by the United States' 1997 Obey Amendment, stopping it from exporting its fighter jet? Japan chose to replace their aging fleet with locally made fighter jets. The FX program took flight on March 2017 when Japan and the United Kingdom signed an agreement to co-develop a future fighter jet. No one really saw Japan's international relations extending as far west as the United Kingdom, but desperate time calls for desperate measures. By 2018, the Japanese Ministry of Defense had a decision to make on the place and model of production of this new production. While they tried to figure that out, they reached out to the United States too, seeking their participation in the creation of an aerial beast like no one has ever seen. As expected, they had offers from top aircraft companies, including Boeing, Lockheed Martin, British Aerospace Systems, and Northrop Grumman. Each of these top aerospace companies had all types of brilliant ideas towards creating an aerial war beast. While Japan was desperate to replace its outdated fleet, it also wanted to make sure that it was on its own terms and on its own turf. As expected, Boeing came with an offer to create an upgraded fighter jet based on their F-15 model, while British Aerospace Systems offered an upgrade on their Eurofighter Typhoon. Japan wasn't having any of it, as they wanted something made locally. They also had no luck with Lockheed Martin, who proposed an F-22 and F-35 hybrid jet. While it sounded like a fantastic idea, it wasn't exactly what Japan wanted: a sense of originality. Hence, they turned it down. Northrop's ideas were no different either. The Japanese Ministry of Defense had completely ruled out the possibility of basing their new aircraft designs on existing models in 2018, but not before giving some consideration to Boeing's F-15 and British Aerospace Systems' Eurofighter Typhoon. Upon their assessment, both jets just didn't meet the Japanese standard. The military of defense considered Lockheed Martin's hybrid stealth aerial combat vehicle, with a collaboration of both the F-22 and 35, but their main concerns stem from the potential cost of the jet, with a whopping $177 million tag estimated for it. Also, the United States banned the exportation of the Lockheed Martin F-22 Raptor in order to safeguard the secret of its technology. As you can imagine, that decision was a bit of an eyesore to Japan, which didn't have its own military and relied on the United States for protection. Hence, they weren't sure if taking on a hybrid of the F-22 and 35 would get the same sanction on exports, so they chose not to take the risk. In 2019, the Japanese military reached a final decision about the future of their fighter jet program, announcing that the fighter jet project will be led by Japan and that while collaboration with other nations isn't ruled out, they will only be a supporting cast. The Japanese Ministry of Defense was very specific about the features they wanted on the next fighter jet, including the capability for future air superiority, the potential to expand capability by incorporating next-generation technologies, affordable cost, and more importantly, the participation of Japanese industry. On the 21st of August, 2019, Japan announced that its fighter jet project would commence in 2020 between April and December, which will be in tandem with the fiscal year budget of 2020. The following year, Japan rejected more designs proposed by Lockheed Martin, Boeing, and British Aerospace Systems. Amidst their decision to include a local Japanese industry in building the fighter jet, the Ministry of Defense enlisted the help of Mitsubishi Heavy Industries, who took the reins of the operation. According to the Acquisition, Technology and Logistics Agency, otherwise called ATLA, the Japanese Ministry of Defense has not ruled out the possibility of international collaboration, even though the conversation for basing their new technology on any of their old ones is a complete non-starter. The Acquisition, Technology and Logistics Agency spokesperson Jane in 2020 reiterated without fail that the Ministry of Defense believes that they have developed enough technology to build the FX locally. By April of the same year, the Acquisition, Technology and Logistics Agency established a dedicated team to develop the FX, but a major general will lead it from the Japan Air Self-Defense Force, who have also dedicated about 30 men to the cause. While the Japanese moaned for freedom to build their own air force in their own way, they still wanted input from other nations, especially the United Kingdom and Italy, which is quite ironic as these two contributed to their downfall during World War II, which relegated them to becoming a pacifist country. On the 9th of December, the Japanese government entered into an agreement with the United Kingdom and Italy, where they merged their concerted effort towards the production of a sixth-generation fighter jet. During the building phase of the Godzilla FX, the common problem of building a stealth jet came into play: the design. The goal was simple. The Japanese Ministry of Defense wanted more than anything to gain air superiority, meaning that they prioritized size as much as they did stealth. The American F-22, whose exportation was stopped from the United States, ranks among the biggest stealth fighter jets in the world. But the Japanese Ministry of Defense wanted the FX to be even bigger, but with sixth-generation features, earning it the nickname Godzilla from Bradley Parrott at Aviation Week, a New York-based publishing and event production company owned by Informa. The company was owned and published by McGraw-Hill until it was purchased by Penton Media in 2013. It is quite a paradox that the FX design prioritizes size, as it is supposed to be a stealth jet, meaning it could literally fly under the radar and avoid detection for as long as possible behind enemy lines. However, the Ministry of Defense has explained its reason for prioritizing size for a stealth jet. The large size indicates that the aircraft possesses very long range and large payload capacity, meaning it could be armed with really heavy missiles and could carry it over a long distance and drop it without fail. Takeru Kano, the Minister of Defense, has also justified the supersize of this supposed stealth jet, boasting that it would carry even more missiles than the massive American F-35 jet. While Japan designed the FX, they used a three-dimensional mock-up system to simulate a test version of the FX, creating a simulation of the assumed function and performance, and then installed a research battle simulator developed by the Technical Research Division. The simulated FX was fed data on stealth, avionics, and engine characteristics. After creating this mock-up, the Japanese Air Force pilots tested it for air-to-air combats, testing the effectiveness and giving their honest assessment on the parts that needed to be reviewed. Compared to the F-2, which uses the conventional hydraulic engines, the FX electric actuators. The actuators are just as functional as the hydraulics, which then brings the question, why fix it when it isn't broken? The Japanese Ministry of Defense had a perfect response, imbued in the difference in complexity between the hydraulics and the electric actuators. The Japanese intelligence is quite convinced that the complexity of designing the interior of the stealth fighter requires a simpler approach than having to build the hydraulics. It is a stealth jet, after all, hence they needed to account for the shape of the aircraft just as much as they prioritized size. Hence they considered the internal weapon bay and the air ducts, which might be a problem should they force the installation of hydraulic system piping due to design considerations such as length and rigidity. Imagine a supposed stealth jet spotted by the length of its hydraulic pipes. Hence, they chose to go with the actuators, which only needed electric wiring. While they prioritized size, they also understood the need to achieve a lightweight body structure. Hence, they delved a little bit away from the conventional use of fasteners and instead used adhesive molding for bonding composite materials. They called it the integrated or fastenerless structure technology. The FX was designed to give high efficiency and high accuracy. Hence, it was only a matter of time before some avant-garde practices were etched into its design for high performance. While the shift away from fasteners solved some of the problems of the FX's weight, the Japanese intelligence believed that more could be done to reduce the weight even further. Hence, after a long time of deliberation, the building team came up with the idea to use heat shield technology as protection for the engines of the FX. This way, they could use aluminum alloys and carbon fiber reinforced polymers in place of conventional material without sacrificing durability or performance. This breakthrough further reduced the aircraft's weight without losing any structural integrity while aiding easy maneuverability in flight. Some say it is a pilot's dream. In contrast to the F-2, which the FX will be replacing, there was a huge focus on molding and the use of carbon fiber reinforced polymer materials to reduce its overall weight. However, the molding technique required fasteners to be placed on only the bottom plates of the wings. In comparison, the FX uses adhesive molding throughout the entire fuselage. According to Japanese intelligence, the new design methods not only retain the structural integrity of the FX, but also reduce the structural mass of the FX airframe by at least 11%. While the design is prominent and has also taken over the aerial warfare space, the avionics of the FX are also second to none. One of the most important features of a stealth aircraft has always been geared towards avoiding detection while also easily detecting other stealth jets around it. To that effect, the FX utilizes integrated sensors, including the Active Electronically Scanned Array, otherwise called AESA radar, a passive radio frequency sensor, and an infrared camera. Both the Active Electronically Scanned Array and radio frequency sensor utilize a gallium nitride to improve their performances. The Active Electronically Scanned Array improves the jet's range and sensitivity, increasing its capability for detecting other stealth jets around, a trait that could come in handy behind enemy lines. The radio frequency helps to identify and locate signals or frequencies emitted by other stealth aircraft, such as radar or communication systems, which may consequently reveal their positions. The FX also possesses a self-defense system that helps it evade and counter air-to-air missiles and surface-to-air missiles. The FX jet produces both electronic countermeasures and support measures to a higher degree than the regular fifth-generation drone. The electronic countermeasure, or ECM as it is popularly called, is aimed at protecting the FX from detection and will also counter enemy jets using different types of countermeasures, including jamming the frequencies by broadcasting strong signals to overwhelm or confuse enemy radar, or deploying signals or systems that mimic the enemy's signals, making it appear as friendly when behind enemy lines or clouds in this case. However, the electronic support measure of ESM in popular parlance aids the FX with detection and surveillance on the enemy. The support measure collects invaluable data on the enemy's position, treats, signal analysis, and helps the pilot create a countermeasure from the collected data for tactical use. The main point of the FX has always been to have a fighter jet with serious stealth features. Hence, to that effect, the Ministry of Defense found numerous ways to avoid having its radar emissions detected. In a bid to minimize radar detection, they used serpentine air ducts and an internal weapons bay as opposed to the F-2's weapon bay. They also applied electromagnetic wave absorbers to the air ducts and engines, grossly reducing the amount of radar reflection. Deflecting radio waves has always been the next step of evolution for stealth combat jets, and the FX has it on lock using plasma stealth antenna technology. The antenna operates in such ways as one would describe a camouflage. It creates a temporary plasma using the features of plasma that can change its physical properties back and forth through electronic control without fail. While the FX might be lightweight, it definitely has enough structural strength and integrity to carry its own arms. In fact, the Anti-Ship Missile 3, or ASM-3, was developed specifically for the FX since the F-2 will be out of commission by the 2030s. The FX will be aimed using a directed energy weapon, or DEW, a ranged weapon that damages its target with highly focused energy without a solid projectile, including lasers, microwaves, particle beams, and sound beams. Potential applications of this technology include weapons that target personnel, missiles, vehicles, and optical devices with high efficiency. While the famous Godzilla FX boasts of serious cutting-edge technology, the future of aerial warfare has shifted largely to unmanned aerial vehicles, like the popular carrier-based X-47B, with a view to reduce casualties and prioritize remote control from land. And the Japanese intelligence seems to share the same sentiment, as the ghost of the Nagasaki and Hiroshima bombings from World War II still stalks them closely. Therefore, losing more people is never an option for the Japanese Ministry of Defense, especially if it is avoidable through technology available to them. Following the design of the FX, the Japanese intelligence decided to introduce their one unmanned combat aerial vehicles, otherwise called the UCAV, that can operate alongside the FX as some sort of shadow guide. The program is called Combat Support Unmanned Aircraft. The drone is rumored to bear a semblance in functionality to the Kratos XQ-58 Valkyrie or Boeing Air Power Teaming System project, in which the drone acts as a loyal wingman to the FX. The Japanese intelligence have decided on creating two drones, one that carries a sensor and scouts for targets, and another that fires the munitions and directs any incoming threats, including air-to-air or surface-to-air missiles, away from the parent aircraft, which in this case is the FX. For Japan, the FX is a way back into the economic powerhouse that once was before the Hiroshima and Nagasaki explosions during the war. While the Godzilla FX might revolutionize aerial combat, it might also be Japan's way to claw back into the spaces where its name was once revered. Following the end of World War II, it is rarely news that the Japanese military defense was completely crushed into oblivion, forcing them to rebuild under the supervision of the United States, which has played Big Brother for too long. While Japan might have relished it as an opportunity to rebuild their economy without worrying about their defense, the times have changed, and so has their mentality. The Asian powerhouse, under the heavy weight of American policies, has been building mainly American-licensed fighter jets, making it impossible for them to build one of theirs. The F-2 was seen as a pure Japanese fighter jet in Japan and was named successor to the old Mitsubishi A6M0. However, the political pressure from the United States forced their hands toward a co-production, which didn't suit the Japanese intelligence. Therefore, when the idea for the sixth-generation FX came into play, the Japanese legislature and defense officials tried to cover their bases properly this time and avoid a repeat of the controversial F-2. This time, they have secured their ground and decided to create their fighter locally, and in case there is a collaboration, a Japanese company, particularly Mitsubishi, will take point. While developing the jet locally gives a sense of pride and accomplishment to the Japanese intelligence and their people, there are doubts swirling around their competence and experience in creating a fighter jet domestically. Reputable individuals like Air Marshal B.K. Pandey, former air officer and commander-in-chief of Training Command of the Indian Air Force, noted that the FX will likely face technological challenges as the technologies used in fighter jets have become more complex over the years. The Godzilla FX jet is on schedule to take over the F-2 in the 2030s. However, as of January 2025, it has not been tested yet, but the first prototype has already been made. Whether Japan's first locally made sixth-generation fighter jet takes over the aerial warfare globally, or gets crushed under another piece of paperwork like the F-2 remains to be seen. Aviation is changing fast. New technologies are making traditional planes look outdated, and the future of flight is no longer bound by gravity. NASA's latest groundbreaking innovation, the anti-gravity dark star, is leading the charge. This jaw-dropping technology with seemingly impossible capabilities will completely revolutionize air superiority. With features that belong in a science fiction movie, this aircraft is about to turn everything people know about aerial combat upside down. Will this unprecedented aircraft disrupt global power structures? How is it changing traditional warfare and pushing technology forward? Join us as we explore how NASA's anti-gravity dark star is rewriting the rules of flight and defense. The United States Air Force has stunned the world with an extraordinary announcement. The SR-72 Dark Star has been officially unveiled in Jerusalem. This revolutionary aircraft represents a quantum leap in aerial technology, featuring unprecedented speed capabilities and advanced systems that eclipse all existing military aircraft. Building upon the legacy of the legendary SR-71 Blackbird, long celebrated as history's fastest and most formidable aircraft, the Dark Star introduces an arsenal of even more astonishing capabilities. The Dark Star was created to replace the famous Blackbird. This new jet aims to fly at about Mach 6, which is over 4,500 miles per hour, twice as fast as the older model. What distinguishes the SR-72 from earlier platforms is its dual-purpose design, combining both intelligence-gathering capabilities with potential strike options. When it was initially revealed to the public in 2013, the SR-72 concept addressed an emerging strategic need for intelligence collection in contested environments, particularly against sophisticated air defense systems deployed by nations like China and Russia. The hypersonic speed profile would allow the SR-72 to penetrate heavily defended airspace, collect vital information, and exit before defensive systems could effectively respond. Despite the promising features, the SR-72 project faced two major challenges. The first was a budget constraint, and the second was the development of new alternatives, such as drones like the RQ-180. As a result, decision-makers began questioning whether it was worth investing in hypersonic aircraft at all. Drones were argued to offer advantages beyond speed. They can stay airborne longer, don't risk pilot lives, and can still gather intelligence effectively. This led to a rethinking of priorities in intelligence-gathering technology. Military planners questioned whether extreme speed was worth the enormous cost when stealth might be more valuable for modern intelligence gathering. This was a practical reassessment based on evolving technology and limited defense budgets. However, despite these budget considerations, the SR-72 has a revolutionary capability that stealth drones simply cannot match. While platforms like the RQ-180 have their place, they lack the game-changing advantage of the hypersonic speed that makes the SR-72 truly irreplaceable. Although the Air Force has not openly acknowledged active SR-72 development, there is good reason to believe a lot of upgrades are happening behind closed doors. In 2013, Aviation Week in Space Technology published a groundbreaking article titled "Meet the Son of Blackbird." This piece revealed Lockheed Martin's ambitious vision to create a successor to one of aviation's most legendary aircraft. The timing was significant, as it marked a renewed interest in high-speed aerial survey capabilities after years of focus on autonomous flight technology. Lockheed Martin, the aerospace giant that originally designed and built the iconic SR-71 Blackbird, proposed developing an entirely new aircraft, rather than simply updating the previous design. What made this proposal particularly fascinating was its propulsion system. The new jet would employ a hybrid approach using both a conventional turbine engine and a supersonic combustion ramjet. This dual-engine configuration would solve one of the greatest challenges of hypersonic flight: the need for different propulsion methods at varying speeds. The aircraft would take off and land using its turbine engine, operating much like traditional aircraft during these critical phases of flight. Once airborne and at a suitable speed and altitude, it would transition to its scramjet engine. This was an engineering feat of remarkable complexity, requiring seamless integration between two fundamentally different propulsion systems. Scramjets operate differently from traditional jet engines. Unlike conventional engines, which rely on turbines and moving parts, scramjets have no moving components. Instead, they harness the aircraft's forward speed to compress the incoming air before burning fuel, enabling the engine to reach extremely high speeds. This unique design makes scramjets ideal for hypersonic flight. The SR-72, unlike its predecessor, the SR-71, was engineered from the start to fulfill multiple roles. While the SR-71 was solely focused on reconnaissance and never adapted for attack missions, despite some early considerations, The SR-72 was designed from the outset to perform both spy and strike missions, combining speed and versatility in one advanced platform. This attack ability fits with the conventional prompt strike idea, hitting important targets quickly without using nuclear weapons. For example, taking out terrorist leaders when they are spotted or destroying missiles with dangerous weapons before they are fired. While the SR-72 wouldn't be as fast as the ballistic missiles normally suggested for these missions, it has other benefits that make it valuable. Despite these amazing capabilities, the jet faced other hurdles beyond its technical challenges. When presented to the Air Force, it remained a proposal rather than an approved development program. Air Force Chief of Staff, General Mark Welsh, publicly stated he did not know about the program. This statement doesn't necessarily reflect the complete picture, as classified programs often operate with extremely limited awareness, even among high-ranking officials. Had circumstances been different, the Air Force would likely have addressed the capabilities of the SR-72 Dark Star openly. However, the secrecy surrounding its design and operational potential has kept the aircraft shrouded in mystery. Therefore, the true extent of the Dark Star's capabilities, its speed, stealth, and reconnaissance power, has been carefully guarded, with only a select few aware of its full potential. This secrecy is consistent with other highly classified programs within the military, many of which remain hidden from public view. According to multiple sources, this new fighter jet was capable of reaching approximately 6,400 kilometers per hour, and what was not mentioned was that development started even earlier. Lockheed Martin formed a strategic partnership with Aerojet Rocketdyne in 2006 specifically to develop the propulsion system that would power the SR-72 Dark Star. This collaboration brought together Lockheed's expertise in advanced aircraft design with Aerojet Rocketdyne's specialized knowledge in rocket and air-breathing propulsion systems. When the Hypersonic Technology Vehicle program was discontinued in 2008 due to funding constraints and technical challenges, Lockheed Martin did not abandon the valuable research that had been conducted. Instead, the company strategically repurposed the supersonic combustion technology that had been under development for the HTV program. This produced the groundbreaking aerothermodynamic duct system installed in the Dark Star. The engine needed to function across all speed ranges, from subsonic, which is below the speed of sound, to transonic, which is near the speed of sound, to supersonic, which is faster than sound, all the way up to hypersonic speeds, which are more than 5 times the speed of sound. The challenge with the aerothermodynamic duct system is that these different engines work best at different speeds, and it created a real problem for fighter jets that need to travel across a wide range of speeds. For example, turbojet engines work well starting from a standstill and hit their sweet spot around Mach 2.2. Once the jet goes faster than that, ramjets become the better choice. These ramjets use the vehicle's forward motion to squeeze incoming air before burning fuel. The downside is that ramjets perform poorly at speeds below Mach 0.5. They only work best around Mach 3 and can keep functioning up to about Mach 6. This is why fighter jets designed for extreme speeds often need multiple propulsion systems to handle the entire speed range effectively. The SR-71 Blackbird initially addressed this challenge through an innovative approach. Its engines were designed with a special technology that seamlessly shifted between traditional turbojets into ramjets for high-speed flight. When the aircraft exceeded Mach 2.5, the airflow would be redirected around the core engine and directly into the afterburner section, essentially converting the propulsion system into a ramjet. They named this technology the turbine-based combined cycle propulsion system. This propulsion architecture represents a sophisticated approach to multi-regime propulsion that leverages complementary thermodynamic cycles within a unified propulsion module. It uses a common inlet and nozzle aperture with bifurcated internal flow paths. This arrangement enables mode transition while maintaining aerothermodynamic efficiency across the functional boundary space, managing the complex shock structures and expansion characteristics required for efficient operation of the fighter jet. Another significant challenge for the fighter jet was extreme heat. At Mach 5 and above, aerodynamic heating generates temperatures sufficient to melt conventional metal airframes. Engineers tackled this problem by researching materials for the most important components. They focused on high-performance carbon composites that offer exceptional strength-to-weight ratios while maintaining structural integrity at extreme temperatures. Ceramic materials became another critical option because they can withstand intense heat without degrading and provide excellent thermal insulation properties. Specialized metal alloys, often containing elements like titanium, nickel, and cobalt, were also developed to maintain their mechanical properties even when subjected to the extreme thermal stress of hypersonic flight. These materials work together to create structures that can endure the intense heat generated when aircraft travel at such incredible speeds, where friction with the atmosphere creates temperatures that quickly destroy conventional materials. NASA took another significant step forward in December 2014 by awarding Lockheed Martin a contract worth $892,292, which is equivalent to approximately $1.13 million in 2023, to investigate the feasibility of the SR-72's proposed propulsion system. This funding supported a detailed design study to evaluate whether the earlier turbine-based combined cycle propulsion system could also be used by integrating existing turbine engine technologies with a dual-mode ramjet capable of ignition at very low Mach numbers. This contract was built upon promising results from a previous NASA-funded Lockheed Martin study, which had determined that speeds up to Mach 7 might be achievable through a revolutionary power plant that seamlessly transitioned between rotary engine and high-speed airflow combustion processes. An example of a fighter jet potentially incorporating this type of technology is the Lockheed Martin X-59 QuiSST, a supersonic aircraft being developed under NASA's Quiet Supersonic Technology program. Engineers have consistently faced a fundamental challenge in developing these advanced propulsion systems. At the lower end of this range, fundamental turbine propulsion technology reaches its performance limits and can't efficiently go faster. Without solving this transition problem, fighter jets would need completely separate propulsion systems for different phases of flight, making them impractically heavy and complex. This problematic speed range has historically represented a significant technological barrier in the development of hypersonic vehicles. In May 2015, reports surfaced revealing that the problems were successfully fixed in Dark Star's system. Notably, these reports left out any mention of payload capabilities, a telling detail in aerospace documentation. This deliberate omission likely stemmed from a significant technical challenge the fighter jet continued to face. Conventional sensors and weapon systems simply couldn't function effectively on an aircraft engineered to fundamentally redefine aerospace possibilities. The extreme operating parameters required for such breakthrough performance created an environment where standard military payloads would be rendered ineffective or even inoperable. The available information about the Dark Star shows it was designed to reach altitudes near outer space. At these extreme speeds and heights, regular military equipment simply wouldn't work. This means engineers would need to develop entirely new weapons and sensors specifically designed to function in these harsh conditions to match the aircraft's remarkable capabilities. Additionally, at such velocities, fighter jets would require hundreds of miles just to execute a turn, creating unprecedented operational constraints. Imagine a car traveling at 1,000 miles per hour on a highway. At this extreme speed, regular brakes would instantly melt from the friction heat. Standard tires would disintegrate from the forces involved. This reality suggests that entirely new generations of sensors and weapons would need to be developed specifically to function effectively under these extreme flight conditions. Despite these challenges, the jet has other interesting features. The fuselage panels were deliberately made to fit loosely when the planes had on the ground. They only lined up correctly once the aircraft heated up during flight, causing the metal to expand several inches. The SR-72 had sharp edges running from its nose down both sides, called Chinese. The first design did not have these at all. While working at the Scientific Engineering Institute, a CIA cover operation, Dr. Frank Rogers made a groundbreaking discovery. He found that the cross-section of a sphere is nearly invisible on radar. Inspired by this revelation, Rogers transformed the conventional cylinder shape by pulling out its sides, creating a unique angular design. This innovation proved to be a game-changer. When a review panel selected Convair's fish configuration over Lockheed's A3, citing its reduced radar detectability, Lockheed swiftly incorporated Rogers' design element, known as Chinese, into their subsequent designs. First, the extra lift from the Chinese allowed engineers to reduce the wing's angle of incidence. This seemingly small change had cascading benefits. It improved stability, reduced drag at high speeds, and enabled the aircraft to carry more weight, particularly additional fuel for extended range. They also improved landing safety. The vortices they created caused turbulent airflow over the wings at high angles of attack, which made the aircraft more resistant to stalling during landing approaches. This turbulent boundary layer helped maintain lift even at slower speeds, allowing for safer landings. Aerodynamicists made another fascinating discovery about these Chinese. They generated powerful vortices of spinning air that created additional lift, an unexpected bonus that significantly improved the aircraft's performance. This discovery transformed the SR-72's design in several important ways. For a typical mission, the SR-72 began its journey with only partial fuel tanks. This deliberate underfueling served two important purposes. It reduced the enormous stress on the brakes and tires during takeoff, since the aircraft was lighter, and it provided a critical safety margin, ensuring the aircraft could still successfully become airborne if one engine failed during this vulnerable phase. The takeoff performance was nothing short of remarkable. Within just 20 seconds of starting its roll, the massive aircraft would cover 4,500 feet of runway and accelerate to 240 miles per hour before lifting into the sky. The climb rate was equally impressive, reaching 20,000 feet of altitude in less than 2 minutes. After that, it would continue its ascent to its typical cruising altitude of 80,000 feet in just 17 more minutes. By this point, the aircraft would have consumed 1/3 of its fuel supply. Many people mistakenly believed that the Dark Star required immediate refueling after takeoff due to supposedly leaky fuel tanks. However, this notion stems from a misunderstanding of the aircraft's innovative design. The fuel tanks were integrated into the outer skin of the aircraft. On the ground, the cold skin would slightly contract, causing minor gaps in the seals. Nevertheless, as the aircraft accelerated and the skin warmed up, the seals would expand and close these gaps, ensuring a tight seal. When refueling the fighter jet, special tanker aircraft called KC-135Qs were essential. These weren't ordinary tankers. They had a modified high-speed boom specifically designed to connect with the Dark Star while flying near the tanker's maximum speed. This was necessary because even at its slowest, the SR-72 was pushing the upper limits of what conventional aircraft could manage. To help pilots during the challenging refueling process, the 72's cockpit featured an innovative instrument called a peripheral vision horizon display. This remarkable device projected a faint artificial horizon line across the entire top of the instrument panel. Though barely visible to direct vision, this line provided subliminal cues about the aircraft's attitude, helping pilots maintain stable flight during the precision maneuver of refueling. In emergencies where a specialized KC-135Q wasn't available, the SR-72 could use any tanker carrying JP-4 or JP-5 fuel to avoid losing the aircraft. However, this came with a significant restriction. The aircraft would need to remain below Mach 1.5, which was substantially slower than its normal operating speed. On particularly hot days, the refueling process became even more demanding. As the aircraft approached its maximum fuel load of 80,285 pounds, approximately 36,415 kilograms, pilots had to run the left engine with minimal afterburner, engaged just to maintain contact with the refueling probe. This delicate balancing act demonstrates the extraordinary precision required to operate the aircraft at the edge of its performance envelope. Comparing both predecessor and successor, the SR-71 Blackbird and the SR-72 Dark Star are two generations of advanced spy planes that broke speed and stealth records. The SR-71, which came first in the 1960s, was built for fast, high-flying reconnaissance missions. It could fly faster than Mach 3 and had room for 2 people, a pilot and a reconnaissance systems officer. Its black paint wasn't just for looks. It helped manage the intense heat from flying so fast. The design featured sharp angles and was made to appear small on radar screens, making it one of the most cutting-edge aircraft of its era. Meanwhile, the SR-72 Dark Star builds on what made the SR-71 great, but with modern materials and newer technology to go even faster. While the SR-71 used jet engines, the SR-72 has a completely different system, a scramjet, that lets it reach hypersonic speeds above Mach 5. This engine breathes air and helps the plane fly faster and more efficiently at extreme heights, making it better for spy missions. The SR-72 is designed to be nimble, with a smooth shape and special materials that can handle the intense heat created when flying so fast. SpaceX has done it again. For years, the F-22 Raptor ruled the skies, but a new powerhouse has arrived. The X-59 flies faster than sound without the explosive sonic boom. Unlike older jets, it moves with stealth and speed, making it a true breakthrough in supersonic flight. With new technology, SpaceX is taking air travel to the next level, leaving countries like Hamas and China behind. What makes this aircraft different? Could it truly replace the legendary F-22 Raptor? Join us as we reveal the mind-blowing features of SpaceX's X-59 supersonic aircraft that is set to replace the F-22 Raptor. For decades, supersonic travel was a dream that came with one big problem, and that is the sonic boom. Every time an aircraft flew faster than sound, it always created a loud explosion that could be heard for miles. This led to strict regulations banning supersonic flights over land. Engineers wanted to solve this issue, but it was not easy to fix. The idea of quiet supersonic travel started in the 1960s, but the technology was not ready. Engineers knew that shaping the aircraft in a different way could reduce the boom, but they did not have the advanced materials needed to make it work. A lot of attempts were made, but the results were not what they wanted. The Concorde is one of the world's most famous supersonic passenger planes that flew at incredible speeds, but its loud boom and high fuel consumption led to its downfall. By 2003, the Concorde was retired, and supersonic travel was forgotten. But NASA was not ready to give up because their aim was to change the way supersonic planes were designed, and they had a plan. Instead of building a commercial aircraft, they decided to focus on an experimental aircraft that could test new technology. This was how the X-59 project began. In 2016, NASA awarded a contract to Lockheed Martin's Skunk Works, a team that is known for creating some of the most advanced aircraft in history. Their mission was simple, and that was to build a plane that could fly at supersonic speeds without the boom. They named it the X-59 QuSST, which means Quiet Supersonic Technology. Skunk Works engineers had to take their time to make plans. They studied how shock waves traveled around an aircraft and used computer models to find the best shape. They discovered that by designing a long, slender body with a specially shaped nose, they could prevent shock waves from merging into a single loud boom. Instead, the waves would be spread out, creating only a soft thump that people on the ground would barely notice. The first major design review happened in 2017. NASA and Lockheed Martin tested small-scale models in wind tunnels to see how the aircraft would behave. These tests helped improve the shape and confirmed that their plan could work. In 2018, NASA officially gave Lockheed Martin the permission to start building the full-scale aircraft. In 2019, the pieces of the X-59 started coming together. The plane was designed to be 99 feet long, with a narrow fuselage and carefully placed wings. Unlike older aircraft, the cockpit was pushed far back, and there was no window facing the front direction. Instead, the pilots would rely on an advanced camera system for visibility. Originally, NASA expected the supersonic aircraft to fly by 2020, but there were delays in construction, testing, and funding that pushed the first flight further. Despite these setbacks, the team did not give up. In 2023, Lockheed Martin released footage of the X-59 rolling out of the hangar, showing the world that the aircraft was almost ready. They confirmed that the X-59 would soon begin test flights. The goal was to fly over selected cities and collect data on how people react to the new, quieter, supersonic sound. If successful, this research could change aviation forever, leading to new commercial aircraft that can fly faster than sound without disturbing people on the ground. One of the most amazing features of this aircraft is its nose. It is longer and more pointed than any other jet, stretching over a third of the plane's total length. This design helps the plane to spread out the pressure waves, stopping them from combining into a loud explosion. Instead of a regular windshield, the aircraft uses an advanced camera system. The external vision system includes a 4K camera that sends a live image to a clear display inside the cockpit. This gives the pilot a better view. It also has special sensors that help detect obstacles and improve visibility in bad weather. The wings of this jet are also different from those of other supersonic planes. They are placed at the back of the aircraft and are thinner than normal. This helps reduce drag and keeps the jet stable at high speeds. The tail of the aircraft is also split into two vertical stabilizers, which help control the movement of the plane and keep it steady in the air. The engine is another important part of the design. The X-59 is powered by a General Electric F-14 engine, the same type used in F-18 fighter jets. This powerful engine allows the aircraft to fly at speeds over Mach 1 without afterburners, making it more efficient and reducing noise. Unlike other supersonic jets, this supersonic jet has its engine intake on top of the fuselage instead of underneath. This helps block engine noise from reaching the ground, making the aircraft even quieter. The landing gear is not custom-made but borrowed from other planes. The front landing gear comes from an F-16, while the rear landing gear is taken from a T-38 trainer jet. This helps save money and speed up production since NASA did not have to develop new landing gear from scratch. Inside the aircraft, the cockpit is designed to be easy to use. The pilot has a modern glass display with digital controls instead of old dials and switches. However, the aircraft's quiet supersonic technology did not only reduce noise, but it also helped with fuel efficiency. Traditional supersonic jets burn a lot of fuel because of the extra drag created by shock waves. But since the X-59 minimizes these shock waves, it can travel faster while using less fuel. This makes it easier for long-distance travel and could help bring back commercial supersonic flights in the future. NASA and Lockheed Martin have also worked hard to make sure the aircraft is safe. Since it is an experimental jet, they have installed multiple backup systems in case something goes wrong. The aircraft is equipped with an automatic flight control system that helps the pilot manage stability at high speeds. It also has emergency landing procedures that allow it to glide safely in case of engine failure. While this jet is not built for combat, its technology has influenced the next generation of fighter jets. If supersonic planes can fly without creating loud booms, military jets can move faster than ever before. One of the biggest reasons this supersonic aircraft is so important is its potential to change aviation rules. The X-59 was built to change the future of supersonic travel, but it was not easy. From the start, engineers had to deal with major obstacles that threatened to slow down and even stop the project. Creating a supersonic plane that does not make a loud boom is not simple. Every part of the aircraft had to be carefully designed, tested, and adjusted. Even with advanced technology, problems kept coming up, forcing NASA and Lockheed Martin to find new solutions. One of the biggest challenges was making sure the aircraft actually reduced the sonic boom. The entire purpose of this aircraft is to prove that supersonic jets can be quiet, but this had never been done before. Engineers had theories, but until the plane was built and tested in real-world conditions, they could not be sure it would work. If the plane failed to reduce the boom, the entire project would be at risk. The long, pointed nose of this plane plays a huge role in controlling sound waves, but it also created a major issue. There was no room for a regular cockpit window, and this meant that the pilots could not see what was in front of them. Another issue was the balance and stability of the aircraft. The unique design of the plane, with its nose and thin wings, meant it had to be perfectly balanced to fly smoothly. Any miscalculation could make it hard to control, especially at high speeds. Engineers ran countless wind tunnel tests and computer simulations, adjusting the wing placement and tail design to make sure the plane would stay stable in flight. The engine placement also created issues. Most jets have their engine intakes on the bottom, but the X-59 has its intake on top to reduce noise. This change affected how air flowed into the engine, making it harder to keep the right amount of power during flight. Engineers had to adjust the design to make sure the engine could have enough air without causing issues that could affect performance. Building the aircraft itself was another challenge. Since it was an experimental aircraft, it was not built like a normal passenger or military jet. Many of its parts had to be custom-made, which took extra time and money. To save costs, the engineers used landing gear from other aircraft, but other components, like the unique nose structure and the cockpit system, had to be built from scratch. There were also delays in production. Designing and testing the aircraft took longer than expected, and some parts were harder to manufacture than planned. Supply chain issues also slowed down production, forcing the engineers to adjust their schedules. One of the biggest concerns was whether the government would actually allow supersonic planes to fly over land. There are strict rules that ban these flights because of the noise they create. The entire purpose of the X-59 is to prove that these rules can be changed, but that decision is not up to NASA. Even if the aircraft works perfectly, governments around the world need to agree that it is quiet enough to allow supersonic travel again. To help convince the governments, NASA has decided to test flights over several cities. These flights will allow people to hear the difference between a regular sonic boom and the quieter sound of the X-59. They will collect feedback from the public and use the data to argue that supersonic flights should be allowed, but there is no guarantee that the tests will be enough to change the laws. Another problem is the cost of future supersonic aircraft. If the technology is successful, it could lead to commercial planes that fly faster than sound. However, building and operating these planes will not be cheap. Airlines will need to decide if they are willing to invest in supersonic travel, and passengers will need to be willing to pay higher ticket prices. If airlines decide that it is not profitable, supersonic travel would not be allowed, even if the technology works. Also, supersonic jets use more fuel than regular airplanes, and fuel costs are a major concern for airlines. Even if this aircraft proves that quiet supersonic travel is possible, engineers will still need to find ways to make future aircraft more fuel efficient. Otherwise, the cost of flying these planes might be too high to make them practical for everyday travel. Another challenge is safety. Since this supersonic plane is a completely new type of aircraft, there is no long history of data to prove how safe it is. While the experts have run countless tests, the real proof will come when the aircraft flies regularly. Any issues that come up during test flights will need to be fixed before supersonic travel can become common. Despite these challenges, the engineers have worked for years to solve problems that once looked impossible. While there are still obstacles to overcome, each test brings them closer to making quiet, supersonic travel a reality. The X-59 is designed to change the future of supersonic travel, but supersonic speed has always been an important part of military air power. The United States Air Force has relied on speed and stealth to dominate the skies for decades. One aircraft that stands out as one of the most advanced fighter jets is the F-22 Raptor, which is set to be replaced by the X-59. This fighter was created to be the ultimate air superiority jet, and it is one of the most feared aircraft in the world. In the 1980s, the United States needed a new jet to replace the older F-15 Eagle and F-16 Fighting Falcon. These aircraft were strong, but military experts knew that future enemies would have better weapons and more advanced fighter jets. The country needed a new fighter that could defeat any threat in the sky. The United States Air Force started the Advanced Tactical Fighter Program, which led to the development of two new aircraft. Lockheed Martin built one design, and Northrop Grumman built another. After years of testing, Lockheed Martin's design won, and the aircraft was officially named the F-22 Raptor. This fighter was built with one purpose, and that is to dominate air combat. It was faster, stealthier, and more advanced than anything that came before it. The first aircraft of its kind was introduced in the year 2005, and it quickly became the most powerful fighter in the world. While the Cold War had ended by the time the aircraft entered service, new threats were beginning to rise. Countries like China and Russia were developing their own advanced fighter jets, and the United States wanted to stay ahead. The F-22 became an important part of the United States Air Force's strategy to keep air superiority. One of the biggest advantages of this jet is its stealth. Enemy radars work by bouncing signals off aircraft, but this plane was built to be almost invisible. Its body is covered in radar-absorbent material, and its shape is designed to scatter radar waves in different directions. Even when enemy radars pick up a signal, it appears as something much smaller, just like the size of a bird. This makes it incredibly hard to track and even harder to lock onto with missiles. Also, this jet could fly faster than the speed of sound without using afterburners. This is called supercruise, and it allows the fighter to cover long distances quickly while saving fuel. Older jets had to use afterburners to go supersonic, which burned fuel fast and made them easier to detect, but it was not a problem for the Raptor. Maneuverability is where the Raptor truly shines. It uses thrust vectoring nozzles, which allow the engines to change direction mid-flight. This means the jet can turn, climb, and twist in ways that other planes cannot. In battles, this gives the pilot an advantage, allowing them to get behind an enemy and fire before they even see what is coming. This aircraft is also loaded with powerful weapons. It carries 6 AIM-120 AMRAAM missiles and 2 AIM-9 Sidewinder missiles for air combat. These missiles can lock onto targets from miles away, striking before the enemy knows what hit them. The jet also has a 20mm Vulcan cannon with nearly 500 rounds, giving it firepower for close-range combat. Aside from that, it can carry 2 1,000-pound GPS-guided bombs, allowing it to take out targets while staying undetected. The cockpit is designed to give the pilot complete awareness of their surroundings. It has 6 color displays that show real-time data on threats, targets, and mission status. A special helmet-mounted display allows the pilot to aim weapons just by looking at a target. This means the Raptor can fire at enemies without even needing to point the nose of the plane at them. The jet's advanced radar system can track multiple targets at once, even from extreme distances. It can detect enemy aircraft long before they come close, allowing the pilot to fire and stay out of harm's way. This radar is also built to resist enemy jamming, making it harder to block or interfere with. It can also gather intelligence. Its sensors can detect enemy movements and share information with other aircraft in real time. This makes it a key part of any mission, helping commanders make better decisions based on the latest data. But as powerful as the F-22 is, it has faced a lot of problems. One of the biggest challenges is its price. This jet was extremely expensive to develop and build. Each jet costs a lot of money, and maintaining them is just as costly. Another issue is that the aircraft has never been exported. Unlike the F-35, which is sold to many allied nations, the Raptor is only used by the United States. This means there is no extra funding from other countries to help with upgrades and maintenance. The entire cost of keeping the jet operational falls on the United States Air Force. Technology has also moved forward since the Raptor was first introduced. While it is still one of the best fighter jets, modern aircraft are being developed with even more advanced systems. Even training pilots for the jet has been a challenge. Since there are so few of these jets, pilots have limited opportunities to practice in them. The Air Force has used flight simulators to help with training, but nothing replaces real flight experience. If the government ever needed to send large numbers of Raptors into combat, there might not be enough trained pilots to fly them. Another problem is that the plane was built mainly for air superiority. While it can strike ground targets, it was not designed for bombing missions like the F-35. The Air Force has tried to upgrade the Raptor to handle more missions. But because production ended early, some improvements have been harder to make. Despite these challenges, this aircraft remains a crucial part of the United States military. The development of the F-22 Raptor and the X-59 shows how much aviation technology has changed over the years. The National Aeronautics and Space Administration is rumored to have created an anti-gravity aircraft that will shatter the laws of physics. While the potential of such cutting-edge technology could create a new phase of aircraft, the intrigue doesn't end there. How does this groundbreaking technology affect aircraft development globally? Could this anti-gravity technology skewer our perceptions of warcraft and space travel as we know it? Join us as we discuss the effect of the National Aeronautics and Space Administration's gravity-defying aircraft. The world is a large space filled with matter and moisture. Hence, for the forces of production and innovation to work, a certain level of force needs to be applied, a fundamental rule of physics. It isn't news that the laws of physics and their application make the world tick. But what happens when someone or some organization decides to decode and recreate those laws? Although Isaac Newton's view of the natural world led to the creation of the popular law of gravity, stating that any particle of matter in the universe attracts any other with a force varying directly as the product of the masses and inversely as the square of the distance between them, the National Aeronautics and Space Administration might have found a way around it with the production of a new cutting-edge aircraft technology that shatters the law to smithereens. Of course, it isn't new to see rules broken or laws flouted. However, some laws are described as primal, almost as if they existed long before the Age of Enlightenment, meaning they were in existence even before the Neanderthals discovered fire. Hence, defiance of these laws by science-oriented eggheads is either directed towards the betterment of technology, improving warfare, or space science. Before the National Aeronautics and Space Administration created a different perspective on anti-gravity aircraft, some personnel, including researchers, scientists, and even terrorist cells, gave it a go. While some failed completely, others had some measure of success, but none have really hit the standards of what the National Aeronautics and Space Administration is rumored to have created. Having an anti-gravity device could do a whole lot of good. Just think about a construction site where a crane is often needed to move heavy objects around. What if there was a device that could afford them a bit of weightlessness, allowing them to move objects around with a limited amount of force applied? It brings everyone to the question, how exactly does the National Aeronautics Space Administration train their astronauts before going to space, where they actually have to deal with weightlessness? Do they have some sort of anti-gravity device that serves their cause? According to Michelle Thaler, one of the National Aeronautics Space Administration's big think tanks, she claims they would have to have some sort of anti-gravity device, hammering on how it could help give the astronauts a bit of groundedness and similitude to a more familiar environment, Earth, even when they are away in space. However, that isn't the case. The astronauts are trained using very specific flight patterns on an airplane. The pilots are trained to fly the aircraft in an arc, then go around again and repeat the same process, creating a short period of weightlessness. Think about Brian Grazer's Apollo 13. The movie absolutely covers the basis of travel and weightlessness in space. But how did they do it? They used the exact same trick. They shot the movie on an aircraft, moving consistently in an arc shape, then filmed per minute. Just imagine the process of feeling some type of weight and suddenly becoming weightless over and over again. It always has an effect on the stomach. Hence, the National Aeronautics Space Administration codenamed the process the Vomit Comet. However, the global space race to create an aircraft so imposing that even gravity cannot hold it together remains an important part of the future of aircraft. Among those who have given it a go is Thomas Townsend Brown, an American physicist who had an obsession with gravity and weightlessness. In 1921, while he experimented in a lab that his parents had set up for him, he discovered an unusual effect while experimenting with a Coolidge tube, a type of X-ray vacuum tube with two asymmetrical electrodes. Brown was convinced that he had been able to influence gravity electrically. However, other eggheads who tried to critique his projects figured out that Brown's thesis might have been groundbreaking, but not in the sense of anti-gravity, but electrohydrodynamics, the movement of charged particles that transfer their momentum to surrounding neutral particles in the air, also called ionic drift or ionic wind. Consequently, the search for answers on anti-gravity remained. While anti-gravity has proven to be elusive over the past couple of years, some warcraft have made serious improvements and possible breakthroughs over the past couple of years, using advanced physics principles to create exotic engines for propulsion in jets, while hoping to break not only the convention speed limits, but also defy gravity by gaining weightlessness. However, they have all mostly fallen short of expectations. It would seem defying a primal nature like gravity is not particularly an easy concept to decipher. Although failures have racked up over time, finally they made a breakthrough with the TR-3B Black Manta. The Black Manta has been allegedly sighted by the Air Force, Marines, and military in the air, performing insane high-degree turns. It is almost like something out of a science fiction movie. While it has not been within sight of the majority of the world, it has been rumored to use an engine that can only be described as anti-gravity. While aviation buffs and unidentified flying objects conspirators have claimed to have seen this aircraft in action, The United States defense has explicitly denied its existence, claiming that the aircraft is non-existent. However, let's face it, the United States defense has never opened up to the multitude about some unidentified flying object, rumored sightings of aliens, or anything out of the ordinary. But how did the Black Manta come into existence, and how exactly does it achieve this anti-gravity state? The TR-3B Black Manta is rumored to use highly pressurized mercury accelerated by nuclear energy, so the plasma is produced, which in turn creates a form of anti-gravity around the aircraft. This unidentified aircraft phenomenon, otherwise called UAP, was first sighted in Britain by the United Kingdom Ministry of Defense. As expected, they kept it under wraps for as long as they could, keeping information about it in classified reports with the codename Project Condé. This includes analyses of black triangle sightings. The declassified report for Project Condé suggests that the sighting could also be due to atmospheric gaseous, electrically charged buoyant plasmas that are capable of being transported at enormous speeds under the influence and balance of electrical charges in the atmosphere. The reports also suggest that some of the sightings of the black triangular-shaped aircraft could also be from meteor entry into the atmosphere. However, many are not completely convinced about the sighting of the shapes. There is an argument that a field with undetermined characteristics can exist between certain charged buoyant objects in loose formation, depending on the viewing aspects, meaning that the sight could be playing tricks on the mind. However, just how many tricks can the eyes play on the mind, especially with numerous sightings? During the early 1980s, several hundred people claimed to have seen some unidentified flying objects flying over the Hudson River in New York City in the United States. This sighting has almost the same triangular shape as the British reports. These sightings involved eerie details of a hovering or slowly flying V-shaped object, brimming with colorful lights. While the sightings began to gain some serious steam, some pilots claimed responsibility for these unidentified flying objects, with explanations that they were ultra-flight aircraft flying in formation. The hypothesis didn't end there either, with speculation rising from the Belgian wave. On the 29th of November, 1990, there was a detailed group of witnesses who claimed to have seen an unidentified flying object with a triangular shape. While some deduced the sightings as a possible proof that aliens do exist among us, others believed that it was indeed the Black Manta. There were 30 different groups of witnesses with 3 other groups of police officers who claimed to have seen the same things. While the words of civilians might carry some doubt, the men in uniform being a part of the witnesses make it a really dicey situation. The black triangle unidentified flying objects have all been claimed to be at least visible on the radar. However, the Belgium sightings, otherwise called the Belgium wave, were more a mystery as there was no real visibility. Some Belgian Air Force F-16s were sent out to intercept the flying object. However, the police report shared with the public claimed that nothing was seen, while aviation buffs believe that the real findings were kept under wraps. Others believe that the police report might be genuine, making it difficult to tell if there actually was a sighting. Guillaume Duhay once said that, to have command of the air means to be in a position to wield offensive power so great it defies human imagination. Now imagine an anti-gravity aircraft used in war, meaning that you could actually fly under the radar behind enemy lines without any form of detection. That changes the entire scope of aerial warfare across the globe, while inevitably sparking a global arms race. It would seem the United States has taken Guillaume Duhay's quote to heart and has now created the absolute air monster to battle Russia, especially. It is no news that the relationship between the United States and Russia has soured badly, especially after the Cold War. This seemingly irreparable relationship between both parties created a necessity for each of them to gain bigger military might than the other. While Russia has displayed the potential to match up to the United States military might, the latter decided to create an aerial monstrosity that puts every competition to the sword. In 1956, the General Physics Laboratory of the Aeronautical Research Laboratories, or ARL, at Wright-Patterson Air Force Base, Dayton, Ohio, created an intense program tasked with carrying out some rigorous research that could lead to a groundbreaking discovery about manipulating gravity and just bending it to their wills once and for all. Imagine having the power to simply turn gravity on and off at a whim. This was America's goal, and they weren't stopping until they got it. While they tried to build, there were some workers who did not really believe that it could be done. Imagine being given a task that goes against everything you have learned as an engineer. Roy Kerr belonged in that group. He was the type who rationalized everything. Hence, if they didn't make sense, he was willing to call it out. According to Kerr, the project was a wild goose chase, and it made no sense to pretend that it was possible. He was convinced that the only real use that the United States Air Force made of them was when some crackpot sent them a proposal for anti-gravity or for converting rotary motion inside a spaceship to a translational driving system. During the following 16 years of the Aeronautical Research Laboratory program, articles were created as conduits to convey the results of their research. However, while the United States played the long game, trying to understand gravity better and see if they could counter it, they forgot about their arch military competition, Russia. The Aeronautical Research Laboratory scientists produced 19 technical reports and over 70 peer-reviewed journal articles, which were rather important to serve as documented findings on their anti-gravity campaign. In the 70s, the United States gathered intelligence about Russia also studying gravity and trying to improve their military might by getting a hang of such a primal beast and then taming it while making it into a weapon of serious destruction. However, it would seem that the National Aeronautics and Space Administration of the United States has beaten Russia to the punch. This anti-gravity aircraft was described to resemble the classic thrill of ufologists. It is built to be capable of hypersonic flight, vertical takeoff, and landing with complete laser weaponry. Talk about cutting-edge aviation technology driven out of necessity. This new aircraft pushes the boundaries of what is thought to be possible in aviation and defense. While some conspiracy theorists have dredged up ideas of this cutting-edge technology only exists as a dream, recent actions from the United States government have given it some verisimilitude. The United States has created some actual space forces that are required to intercept some familiar problems in space. What better way to do that than with an anti-gravity aircraft? However, skeptics and aviation buffs believe that it's nearly impossible to create an aeronautical monster of that power, as it would require certain equipment that is factually hard and nearly impossible to get. For example, the TR-3 Manta B is supposedly expected to have a much more powerful engine than the conventional jets. Powering an aircraft that could go against gravity would require an enormous power source, much more than what is expected of any unmanned combat vehicle or other powerful aircraft. However, it is quite interesting that Lockheed Martin holds a patent for small coal fusion reactors compact enough to fit in an F-16 Raptors fighter. This suggests that a similar energy source could be used in futuristic aircraft. Another intriguing development involves Dr. Salvatore Pais, a reported aerospace engineer linked to the United States Space Force. In 2020, the United States Navy reportedly filed patents for groundbreaking technologies, including gravitational wave generators and space-time manipulation weapons. While the technologies in question sounded quite outlandish and near impossible. However, over the years, science has seen too many loopholes corrected and laws rewritten, making it impossible to throw out the possibility. Despite the skepticism and criticisms flowing around establishing such pseudo-scientific concepts, the United States Navy had already invested too much of their time, money, and resources, and they weren't going back home. While the Manta continues to create a division in public opinion and perception of the government, other cutting-edge stealth jets were created in that time, providing some hope that the Manta is actually a possibility. The Northrop Grumman B-2 Spirit, or stealth bomber, as it is popularly called. This stealth jet was developed between 1989 to 2000. Its capabilities have often been described as being outside of this world, as it has the capability to carry both conventional and nuclear weapons. Talking about weapons and systems created out of necessity, the Northrop B-2 stealth bomber is right on top of the pile. Aircraft superiority has always been the name of the game, and the superpowers in the world remain in contest for superior military might. The B-2 was created to change the state of aerial warfare. At the time, not many could place a finger on a way to avoid counter-aircraft. Hence, they introduced stealth. The concept was to build an aircraft with an airframe that deflected or absorbed radar signals so that little was reflected back to the radar unit. An aircraft having radar stealth characteristics would be able to fly nearly undetected and could be attacked only by weapons and systems not relying on radar. Although other detection styles existed, especially infrared in the human eyes, they were low technology and just couldn't match up to the technology at the time. The B-2 was more lethal than the average fighter jet at the time. Fast forward to the 21st century, where there is an established presence of unmanned combat vehicles, otherwise called the UCAVs. The B-2 was different. It was completely manned. It needed a pilot to direct its long bombs and fly them behind enemy lines. However, its development was handled differently, unlike the aircraft built before it. During its design and development, the Northrop B-2 program was a black project. All program personnel needed a very high security clearance. However, even though it required extra clearance to see the project, it was actually not kept as close to the vest as the F-117 project. The President of the United States at the time took the word stealth to another level, as he was rather adamant that every member of staff working on the B-2 in most, if not all capacities, needed a level of special access clearance and undergo a super thorough background check, which was to be carried out by a special branch of the United States. These acts of secrecy and bits of cloak and dagger led to a lot of questions about this aircraft, with some people questioning its reality, while others claimed that it was a social experiment to test the patience of Americans to see how they react to a failed promise of a never-before-seen stealth weapon. However, the Kosovo War in 1999 ended all the cloak and dagger. It was, in fact, responsible for destroying 33% of selected Serbian bombing targets in the first 8 weeks of the United States intervention and involvement in the war. While some believe that they intervened as an opportunity to test their nuclear menace. Whether that is true or not, nobody really knows. However, during this war, 6 B-2 flew in a non-stop flight to Yugoslavia from their home base in Missouri and back, using no less than 30 hours. Although the bombers accounted for 50 missions out of a total of 34,000 North Atlantic Treaty Organization missions, they dropped 11% of all bombs. By all standards, it was a successful mission and a successful debut for the aircraft. Just as unbelievable as the B-2 was, the Manta has allegedly come to kick up the same fuss, taking charge of the air battles and making the United States top dog in aerial combat. While no one knows when the anti-gravity aircraft will be debuted, the world waits in anticipation. America's deadliest weapon makes it impossible for its enemies to feel safe. The $500 million supersonic bunker buster has rewritten warfare. This 30,000-pound beast, built to penetrate 200 feet of rock, recently stunned the world in Yemen, completely obliterating reinforced bunkers with ease, leaving military experts in awe and adversaries terrified. Is this the end of underground hideouts? And what happens when this unstoppable force targets Iran's deepest bunkers? Join us as we find out what makes the $500 million supersonic bunker buster a game-changer. On October 17th, America's most powerful non-nuclear weapon struck Yemen, marking a turning point in modern warfare. The United States Air Force unleashed its massive GBU-57 bunker buster bombs on 5 hidden targets, using the rare B-2 stealth bomber for the first time in the Middle East conflict. The targets weren't ordinary military bases. They were deep underground facilities near Yemen's capital, Sana'a, and the northern stronghold of Sada, where Iran-backed Houthi forces stored missiles and drones. These caves and tunnels, some dating back to the 1980s, had survived countless attacks before because they were too deep for regular bombs to reach. The strike came after Houthi forces attacked over 80 ships in the Red Sea since October 2023, disrupting global trade. The Houthis claimed they were targeting vessels connected to Israel, but many attacked ships had no links to Israel at all. Recently, the Houthis even threatened to expand their attacks to the eastern Mediterranean using new Iranian missiles. What made this strike special was the GBU-57 bomb itself. At 30,000 pounds, about the weight of 2 adult male elephants, this weapon can drill through 200 feet of solid rock before exploding. Regular bombs would just bounce off or make small dents in these bunkers, but the GBU-57 was designed specifically to destroy these underground hideouts. United States Defense Secretary Lloyd Austin said the strike sent a clear message. No target is too deep or too strong to hit. But the message wasn't just for Yemen, it was also meant for Iran, showing what could happen to their underground nuclear facilities if tensions got worse. The attack hit 3 missile bases near Sana'a, Jabal Atan, Al-Hafa, and Nandain, plus a tunnel complex near Sada's airfield. These sites house missiles that could reach not just nearby ships, but targets thousands of miles away. While the Yemen strike showed the bunker busters' devastating power, what makes this 30,000-pound behemoth so special that even the world's strongest bunkers can't stop it? The GBU-57 massive ordnance penetrator is unlike any weapon ever built. Its massive metal case is filled with over 5,300 pounds of powerful explosives, enough to destroy multiple football fields of underground structures. But raw power isn't what makes this weapon unique. The bomb's nose is made from a special hardened steel that stays strong even when hitting reinforced concrete at supersonic speeds. Inside, advanced computers and GPS sensors guide it to hit targets with incredible accuracy. When the bomb strikes, it doesn't explode right away. Instead, it uses its weight and speed to drill deep underground, only detonating once it reaches the target. This technology didn't appear overnight. It started in World War II when British engineer Barnes Wallis created the first bunker busters, the Tall Boy and Grand Slam bombs. These early weapons showed that a heavy bomb dropped from a high altitude could pierce deep underground. The United States military took these lessons and kept improving the design. During the Cold War, as countries built deeper bunkers, the need for better bunker busters grew. This led to the GBU-28, a 5,000-pound weapon that could break through 20 feet of concrete. But even this wasn't enough for some targets. That's why the United States developed the GBU-57. At 6 times heavier than the GBU-28, it can smash through 61 meters of concrete taller than a 20-story building. Or it can pierce 38 meters of solid rock before exploding. Its advanced guidance system is so precise it can hit within inches of its target, even from miles high in the sky. Only the B-2 Spirit stealth bomber can carry this massive weapon. The bomb is so heavy that each B-2 can only carry 2 at a time, tucked away in special weapons bays designed just for these massive weapons. With such incredible power and advanced technology packed into each bunker buster, how much does it cost to build these underground destroyers? And what does it take to keep them ready for action? Creating the world's most powerful non-nuclear bomb doesn't come cheap. Each GBU-57 bunker buster costs $3.5 million to build, which is about the same as 10 average American homes. But that's just for one bomb. The entire program to develop these weapons cost between $400 and $500 million, enough money to build a small fleet of Navy ships. Compare this to regular bombs. A standard 2,000-pound smart bomb costs about $26,000. The huge price difference comes from the special materials and complex technology inside each bunker buster. The hardened steel case alone costs more than many luxury cars, and the guidance computers and sensors add millions more to the price tag. But the real money goes into the B-2 Spirit stealth bomber that carries these weapons. Each B-2 costs $2 billion, as much as building 4 large hospitals. The United States Air Force only has 20 of these planes, making them some of the rarest aircraft in the world. Keeping these bombers ready to carry bunker busters is an enormous task. Every 7 years, each B-2 needs a complete overhaul that costs $60 million and takes an entire year to finish. During this time, teams of specialists take apart the entire plane, check every part, and replace anything that shows wear. The daily upkeep is just as demanding. For every hour a B-2 spends in the air, it needs 50 to 60 hours of maintenance on the ground. This means if a B-2 flies a 12-hour mission, mechanics will spend about a month working on the plane before it can fly again. Special climate-controlled hangars keep the B-2's sensitive stealth coating in good condition. These hangars cost millions to build and maintain. The Air Force even uses special tape and paint that won't damage the stealth coating when mechanics work on the plane. The bunker busters themselves need careful handling too. Special trucks transport them in padded containers, and teams regularly check the explosives and guidance systems to make sure they'll work perfectly if needed. Each bomb sits in a climate-controlled storage bunker until it's loaded onto a B-2 for a mission. With billions spent on these powerful weapons, what kind of underground fortresses are the Houthis building that made the United States bring out its most expensive bunker busters? The Houthi forces in Yemen have built one of the world's most complex underground networks, turning natural mountain caves into military strongholds. These aren't simple tunnels. They're modern fortresses buried deep in Yemen's rugged mountains, some reaching hundreds of feet below ground. Over the past decade, the Houthis have transformed old smuggling routes and natural cave systems into military bases. They've lined tunnel walls with reinforced concrete and installed heavy steel doors that can withstand regular bomb blasts. Inside these hidden bases, they store missiles, drones, and other weapons away from spy satellites and regular airstrikes. The tunnel network spreads like a spider web under Yemen's northern mountains. Some tunnels connect to launch sites for missiles and drones, while others lead to storage rooms packed with weapons. The Houthis even built underground command centers with their own power supplies and air systems, allowing them to survive long periods underground during attacks. What makes these bases so hard to destroy is their smart design. The entrance to a weapons storage area might be in one mountain, but the actual storage rooms are under a different mountain hundreds of yards away. The Houthis also built fake entrances and dummy sites to fool attacking forces. They use small drones to watch for incoming aircraft, giving them time to move weapons and fighters through the tunnels before an attack. These drones also help them map new tunnel routes and find natural caves they can expand into bases. The Houthis learned these tunnel building skills from Iran, which has its own massive underground military bases. Iranian engineers helped design the Yemen tunnels to withstand most bombs. They added air vents disguised as natural rock formations and built blast doors at angles that deflect bomb explosions. Regular bombs bounce off these reinforced tunnels or only damage the entrance. Even if a bomb gets through the first layer of protection, the Houthis built their storage rooms and command centers so deep that normal bombs couldn't reach them. This is why the United States had to use its special bunker busters. They're one of the few weapons that can drill deep enough to hit these hidden bases. With the Houthis building such sophisticated underground networks, how does America use weapons like the bunker buster to stop enemies from attacking in the first place? The United States military has a smart strategy called conventional deterrence, showing enemies that fighting would cost them too much to be worth it. It's like having a big guard dog in your yard. Most people won't try to break in because they know the risk isn't worth it. That's what the bunker buster strikes in Yemen were really about. Sending a message. When countries see weapons like the GBU-57 in action, they think twice about starting trouble. The United States military carefully plans these demonstrations of power. They don't just drop bombs, they show that they can find hidden targets, strike them precisely, and destroy them completely. Speed is a key part of this strategy. In Yemen, the United States went from spotting Houthi attacks on ships to striking their underground bases in just days. This quick response tells other countries that they can't hide or prepare if they start a fight. The military uses three main tools to make this strategy work. First, they need weapons that everyone knows can do serious damage, like the bunker buster. Second, they need to prove these weapons actually work by using them successfully. Third, they need to make sure potential enemies know about these demonstrations of power. That's why the United States Defense Secretary talked openly about the Yemen strikes. He wanted Iran, North Korea, and others to see that their underground bases weren't safe. The military even released photos of the bunker buster at Whiteman Air Force Base, home of the B-2 bombers, as another subtle warning. But conventional deterrence isn't just about scary weapons. The United States also shows off its precision targeting, cyber capabilities, and ability to find hidden bases. They want potential enemies to know that starting a fight means facing not just one weapon, but a whole system of advanced military tools. This strategy has worked well since the Cold War. Many countries have chosen not to attack American forces or allies because they've seen what United States weapons can do. The bunker buster is just the newest tool in this long-running approach to preventing wars before they start. While showing off powerful weapons helps prevent wars, who else besides Yemen is worried about America's bunker busters, and what are they hiding underground? The Yemen strikes sent shockwaves far beyond its borders, especially to countries with their own underground military bases. Iran, which helped the Houthis build their tunnels, watched closely as the bunker busters drilled through defenses they thought were safe. Iran has built many of its nuclear facilities deep underground. Their main uranium enrichment plant at Natanz sits under 25 feet of concrete and is buried inside a mountain. For years, they believed these facilities were too deep for any weapon to reach. The bunker buster strikes in Yemen proved them wrong. North Korea paid attention too. They've built 3 rings of underground bases around their country. The closest ring sits 50 miles from South Korea and holds short-range missiles. A middle ring, 90 miles back, contains medium-range missiles. The farthest ring, over 150 miles from South Korea, hides their longest-range missiles that can hit targets thousands of miles away. These bases aren't simple bunkers. North Korea dug them into mountains, adding thick concrete walls and heavy steel doors. Some have their own power plants, air systems, and living spaces for hundreds of soldiers. They even built fake entrances and dummy sites to fool spy satellites. China watched the strikes carefully. Their underground submarine base at Yulin on Hainan Island was built to hide their nuclear submarines from spy satellites. In August 2020, satellites caught rare photos of a nuclear submarine entering the underground dock. The base has tunnels big enough for submarines to enter directly from the ocean, keeping them hidden from view. The bunker buster strike showed these countries that their underground bases weren't as safe as they thought. But hitting these bases would be risky. Both North Korea and China have nuclear weapons. While they might not use them first, they might respond with nuclear weapons if their underground bases were attacked. The strikes also helped Israel, which is worried about Iran's underground nuclear program. By showing that bunker busters can destroy these bases, the United States sent a clear message. If Iran causes trouble, its underground facilities can be hit. This gives the United States more power in talks with Iran about stopping its nuclear program. While bunker busters can destroy underground bases, who goes in to check the damage and handle dangerous weapons inside? Meet the robots changing the face of modern warfare. The United States military is building an army of robots to help soldiers do dangerous jobs more safely. These aren't the walking, talking robots from movies. They're real machines designed for specific military tasks, from lifting heavy weapons to checking destroyed bunkers. The Guardian Exo looks like a metal suit that soldiers wear. This powered exoskeleton helps them lift 200 pounds as easily as 10 pounds. Soldiers can work for 8 hours straight wearing it, carrying heavy ammunition, or moving wounded teammates to safety. Special sensors in the suit copy the soldier's movements exactly, making it feel natural to use. Then there's Big Dog, a 4-legged robot that looks like a headless metal mule. It can carry 750 pounds of supplies across the rough ground where trucks can't go. Special leg joints help it balance on ice or climb steep hills, and it can even get back up if it falls over. Soldiers use Big Dog to carry extra ammunition, food, and medical supplies during long missions. The most impressive might be Eagle Prime, a 12-ton combat robot as tall as a house. It carries both a heavy machine gun and a grappling hook, letting it fight enemies or move heavy objects from a safe distance. 2 operators control it from inside. One drives while the other handles the weapons. For checking dangerous areas like destroyed bunkers, the military uses the FLIR Cobra. This tank-like robot has cameras that can see in the dark and sensors that detect poisonous gases or radiation. Its arm can lift 330 pounds and handle bombs safely, keeping soldiers away from explosions. The newest addition is the T-360M2 MUT, a robot that can switch between wheels and tracks like a tank. It can drive for 3 days without refueling and carry 433 kilograms of equipment. Special cameras help it drive itself, following soldiers automatically while carrying their supplies. These robots work together with regular soldiers. The Guardian XO helps load missiles onto planes. Big Dog carries supplies. Eagle Prime provides cover fire. FLIR Cobra checks for dangers. And the T-360M2 MUT brings up extra ammunition. They're already changing how the military fights, making missions safer and soldiers stronger. These military robots are impressive on their own, But what happens when we add artificial intelligence to the mix? And how close are we to robots fighting battles on their own? The United States military is adding smart computer brains to its combat robots, creating machines that can think and act without constant human control. These robots use artificial intelligence to make quick decisions in dangerous situations. But humans still decide when and how to use them. The newest military robots have special cameras and sensors that work like human eyes and ears. They can spot hidden enemies, detect poison gas, and even find buried bombs. Some robots use heat sensors to see through walls, while others have sound detectors that can hear vehicles from miles away. Military scientists have taught these robots to work as teams. When soldiers search a dangerous area, flying drones scout ahead while ground robots follow behind. The drones send pictures to the ground robots, which use AI to plan safe paths forward. Soldier-worn computers show all this information in real time. These robots learn from experience. Each time they complete a mission, their AI remembers what worked and what didn't. For example, bomb disposal robots now know hundreds of ways to handle different explosives safely, thanks to years of collected data from real missions. But the military keeps humans in control. Each robot has multiple safety systems that prevent it from acting without permission. Even the most advanced AI can't fire weapons or make big decisions without a human saying, okay. This rule is built into every military robot's programming. The next big step is teaching robots to help in medical emergencies. New rescue robots can find wounded soldiers using heat sensors and carry them to safety. Some even have built-in medical sensors to check vital signs and help medics treat injuries faster. The military also uses these technologies to train soldiers. Special computer systems create virtual battlefields where soldiers practice working with robots before real missions. This helps them trust the robots and learn how to use them effectively. These advanced technologies are changing how the military handles dangerous jobs, making missions safer for human soldiers. But they're tools, not replacements. The goal is to have robots handle the riskiest tasks while keeping humans in charge of the important decisions. The world has been at a standstill since NATO's deadliest weapons took flight. This new fighter jet, costing $13 billion, is packed with the latest technology and hidden strength. It moves like a shadow but hits like a storm. With global tensions rising and rival nations showing off their power, NATO's latest machine is ready for action. Will it keep the peace with its strength, or will it push the world toward a new arms race? Join us as we find out about NATO's new gigantic $13 billion fighter jet that is being tested. When 13 powerful nations joined forces to build a fighter jet, they did not just create another airplane, they created a flying supercomputer that changed everything about modern warfare. The F-35 has become the backbone of Allied air power worldwide, with more countries lining up to get their hands on this remarkable machine. Built through an incredible team effort, the F-35 brings together government allies and aerospace experts under the watchful eye of the Pentagon's Special F-35 office. All three branches of America's military, the Air Force, Marine Corps, and Navy, fly these jets, each using them in different ways to match their unique missions. What makes the F-35 special is not just its speed or weapons. This fighter works like a flying command center, gathering massive amounts of information from its advanced sensors and sharing it instantly with ships, ground forces, and other aircraft. From its higher position above the battlefield, the F-35 can spot threats that others miss and warn everyone connected to its network. Each F-35 costs about $80 million, which is actually less than many expected for such advanced technology. The jet features special materials and shapes that make it nearly invisible to enemy radar. Its helmet alone costs $400,000 and lets pilots see through the aircraft using cameras mounted outside, giving them a 360-degree view of everything around them. The F-35 can carry up to 18,000 pounds of weapons while maintaining its stealthy profile. It reaches speeds of Mach 1.6, about 1,200 miles per hour, and can fly more than 1,350 miles without refueling. Inside, the cockpit has a large touchscreen display instead of dozens of switches and dials found in older jets. Beyond military benefits, the F-35 program supports over 254,000 American jobs across 45 states. Workers build everything from tiny electronic components to massive wing sections, creating the most advanced fighter jet the world has ever seen. For pilots, the F-35's greatest gift is survival. Its technology keeps them safer than ever before against modern threats, allowing them to complete their missions and return home, which is the ultimate measure of any warplane's success. While the F-35 excels as the ultimate team player in the sky, another American fighter jet holds the title of the most feared dogfighter ever built. What makes the F-22 Raptor so special that even America's closest allies aren't allowed to buy it? The F-22 Raptor remains the most advanced air combat machine ever built. As the first fifth-generation fighter in the United States Air Force, this single-seat twin-engine jet redefined aerial warfare. Unlike the widely used F-35, the F-22 is exclusively American. In 1998, Congress banned its export to keep its technology secret. Only 187 were built before production ended in 2011, making each one a rare and valuable asset. The Raptor earned its name from its hunting skills and bird-like flight. It reaches speeds of Mach 2.25, about 1,500 miles per hour, and climbs at 62,000 feet per minute. At combat altitudes, it flies 600 miles without refueling, while keeping its weapons hidden for stealth. Its defining ability, Super Cruise, lets it fly faster than sound without afterburners, unlike most jets that need extra fuel to break the sound barrier. This allows the F-22 to stay supersonic longer, making it far more efficient in combat. Inside the cockpit, pilots use advanced radar to follow 30 targets at once from over 100 miles away. The onboard systems merge sensor data, giving a complete view of air and ground activity while staying nearly undetectable. F-22 squadrons, stationed across 7 United States Air Force bases, can deploy worldwide in hours. They specialize in eliminating enemy aircraft so other forces can operate safely. In exercises against older F-15 and F-16 fighters, a single Raptor can defeat multiple opponents without being seen. Despite its age, the F-22 keeps evolving. Constant upgrades ensure it will dominate the skies until at least the 2030s. Even after 25 years, no other fighter matches its speed, stealth, and combat superiority. While the F-22 Raptor represents the pinnacle of modern stealth technology, another legendary American fighter continues to dominate the skies after nearly 5 decades of service. How has the F-15 Eagle managed to remain one of the world's deadliest combat aircraft since the Vietnam War era? The F-15 Eagle remains one of the most successful fighter jets in history. First flown in 1972, this twin-engine powerhouse has an unmatched combat record of 104 victories with no losses. Unlike the stealth-focused F-22, the F-15 was built for sheer performance. Its massive engines generate over 29,000 pounds of thrust each, allowing the 68-foot aircraft to climb 30,000 feet in 60 seconds. With its large fuel capacity, it can patrol for hours, while its airframe withstands 9 times normal gravity in high-speed combat turns. The Eagle has evolved across 5 decades, with the original F-15A leading to variants like the F-15E Strike Eagle. This 2-seat version added precision bombing to the Eagle's air superiority, making it a lethal force in both air and ground attacks. Major Thomas Schimmer, an F-15 instructor with over 2,000 flight hours, once noted that the Eagle's power and handling allow pilots to focus on tactics rather than the aircraft's limits. Its advanced radar detects fighter-sized targets over 100 miles away, while its bubble canopy gives pilots clear visibility in all directions. The F-15 has dominated conflicts from the Middle East to the Balkans, where American, Israeli, and Saudi pilots have consistently outperformed Soviet-designed aircraft. While the F-22 operates as a stealth fighter, the F-15 remains a reliable workhorse. The latest F-15EX Eagle II costs about $80 million, far less than the F-22's $150 million price tag. Modern F-15 models feature digital cockpits, helmet-mounted targeting, and electronic warfare systems that detect and jam enemy signals. Some can even control swarms of autonomous drones. As NATO faces growing threats, the F-15 will continue to defend American skies well into the 2050s, proving its legendary design remains unmatched. While the F-15 Eagle commands respect through its raw power and size, its smaller American cousin has become the most widely used fighter jet on Earth. How did the nimble F-16 evolve from being nicknamed the Lawn Dart into the advanced Block 70 to 72 that countries around the world are lining up to buy? The F-16 Fighting Falcon proves that smaller can be better. Designed in the 1970s as a lightweight daytime fighter, it has evolved into one of the most versatile combat aircraft. The newest Block 70 to 72 models represent its most advanced form. Unlike the larger twin-engine F-15 Eagle, the F-16 follows a simpler design. Weighing less than half of an F-15 and powered by a single engine, it is far cheaper to buy, fly, and maintain. Each F-16 costs about $30 million compared to the F-15's $80 million price tag. What sets the F-16 apart is its agility. It was the first jet designed with relaxed static stability, making it naturally unstable. While this may seem dangerous, computerized flight controls allow sharper turns and faster maneuvers. Instead of a traditional center stick, pilots control the jet with a side stick similar to a video game joystick. The Block 70 to 72 models extend airframe life by 50%, allowing each jet to fly 12,000 hours or over 25 years. These upgrades include an advanced radar system, large color displays replacing old gauges, and a new autopilot for long missions. A helmet-mounted sight lets pilots aim weapons simply by looking at targets. Defense analyst Maria Rodriguez states that the F-16's adaptability is its greatest strength. Though first flown in 1974, continuous upgrades have kept it relevant for 5 decades. More than 4,600 aircraft have been delivered to 25 countries, with 5 nations already ordering the latest model. Despite lacking stealth, the F-16 Block 70 to 72 integrates advanced electronic warfare systems and precision-guided weapons. With global tensions rising and defense budgets tightening, this fighter offers an ideal balance. Advanced enough for modern combat, yet affordable enough to field in large numbers. Nearly 50 years after its first flight, the Fighting Falcon remains a trusted choice worldwide. While fighter jets like the F-16 win battles through speed and firepower, modern air warfare depends on something even more valuable: information. How does Israel's flying radar system give smaller nations the same battlefield awareness that only superpowers once possessed? The IIAI ELM 2075 Falcon does not drop bombs or fire missiles, but it is one of the most important aircraft in modern air forces. From the outside, it looks like a passenger plane with a large bump on top. Inside that bump lies advanced technology that can change the outcome of wars. Built by Israeli Aircraft Industries and Elta Electronics, the Falcon turns aircraft like Boeing 767 and C-130 transport planes into powerful flying radar stations. Unlike fighter jets, which serve only one nation, the Falcon system has been sold to several countries looking to protect their airspace without spending billions. Former Israeli Air Force Commander Eitan Ben-Eliyahu describes it as a flying control tower that can detect threats and direct air defenses effectively. The heart of the Falcon is its active electronically scanned array radar. Unlike older rotating radars, this system uses thousands of tiny modules that instantly switch frequencies and focus power in specific directions, making it harder to detect or jam. The Falcon can identify an aircraft in under 4 seconds, 5 times faster than older systems. This speed is critical in modern air combat, where battles are decided in minutes. It can track dozens of targets at once, distinguish between friendly and enemy aircraft, and detect low-flying cruise missiles that ground-based radars might miss. Secure data links instantly share this information with fighter jets, ground defenses, and command centers over long distances. Countries like India, Chile, and Singapore have purchased Falcon systems. For the price of a few fighter jets, about $250 million per system, these nations gain surveillance over vast airspace. Unlike American AWACS planes that require specific Boeing aircraft, the Falcon can be installed on different airframes, saving money and simplifying maintenance. Inside, operators analyze radar data, identifying threats and preventing conflicts. Defense analyst Sarah Bronstein calls it a force multiplier, making every aircraft and defense system more effective. The latest versions use artificial intelligence to detect unusual flight patterns, improved communications to coordinate with naval forces, and electronic warfare capabilities for self-defense. As military threats evolve, the Falcon ensures that nations see first, making victory possible without a single shot fired. While Israel's Falcon system represents cutting-edge modern technology, some Cold War aircraft continue to serve effectively in today's air forces. How did a fighter bomber designed to stop Soviet tanks in Europe become one of the most versatile combat planes of the last half-century? The Tornado IDS emerged during the Cold War when the Soviet threat loomed over Western Europe. Unlike American jets designed by single companies, the Tornado was a joint effort by Germany, the United Kingdom, and Italy, nations that combined their engineering expertise to create a versatile combat aircraft. In the 1970s, these countries needed a plane that could fly low and fast in any weather, day or night, to counter Soviet tanks advancing through Germany. The result was the Tornado, a twin-engine jet built for extreme conditions. Former German Air Force pilot Hans Müller explains that pilots trained to fly as low as 200 feet at nearly the speed of sound, staying hidden from enemy radar. A defining feature of the Tornado is its variable sweep wings, which change position during flight. For takeoff and landing, they extend straight for maximum lift, and during high-speed flight, they sweep back to reduce drag. This gives the Tornado its distinctive transforming shape. Another rare feature is its thrust reversers, which redirect engine thrust forward, allowing it to land on short runways, sometimes needing only 2,000 feet instead of the usual 8,000. This ability let Tornado squadrons operate from damaged airfields or highways if main bases were attacked. Inside the cockpit, the pilot flies while a weapons systems officer handles navigation and targeting. This teamwork is crucial for complex, low-level missions. The Tornado's firepower includes two 27mm cannons firing 1,700 rounds per minute, as well as bombs ranging from simple unguided munitions to laser-guided precision weapons. In a specialized role, it carried anti-radar missiles to destroy enemy air defenses. Although designed for European conflicts, the Tornado made its combat debut in the Gulf War of 1991. British and Italian crews flew deep into Iraq, some completing over 40 combat missions. Later, German Tornadoes participated in NATO operations in Bosnia and Kosovo, while British jets saw action in Afghanistan, Iraq, and Libya. Defense analyst Elizabeth Harmon credits the Tornado's longevity to constant upgrades in sensors, weapons, and electronic systems. While many have retired, Germany still operates a reconnaissance squadron equipped with advanced cameras and sensors. While the Tornado represented European cooperation, other nations chose to maintain their own independent fighter programs. How did France's sleek Delta-wing Mirage 2000 become such a successful export that it now guards the skies of countries across 4 continents? The Mirage 2000 streaks through the sky as a symbol of French aviation pride. Created by Dassault in the early 1980s, this fighter jet continues France's tradition of building advanced combat aircraft independently. Unlike the bulkier Tornado with its moving wings, the Mirage 2000 has a delta wing, a sleek triangular shape without a separate tail. This design provides excellent speed and agility while keeping maintenance costs low. Former French Air Force commander Jean-Paul Martin describes it as an elegant engineering solution that maximizes performance without unnecessary complexity. France's Air Force received the Mirage 2000 in 1984, but its success extended far beyond. Countries such as India, Egypt, Greece, Peru, and Taiwan chose it for their fleets. India, which operates more than 50 Mirage jets, used them effectively during the 1999 Kargil conflict, striking enemy positions in the Himalayas with precision. The Mirage comes in specialized versions. The Mirage 2000C is a single-seat air defense fighter, while the Mirage 2000D was developed for precision bombing. The Mirage 2000N carries nuclear weapons, ensuring France's independent nuclear strike capability. Inside the cockpit, the Mirage features a digital glass display system that enhances targeting. It reaches speeds above Mach 2 and climbs to 60,000 feet higher than commercial airliners. With a combat radius of about 850 miles, it can patrol vast areas or strike deep behind enemy lines. For air-to-air combat, the Mirage carries the French-made MICA missile, capable of hitting targets beyond visual range. For ground attacks, it uses laser-guided bombs and Apache standoff missiles, allowing strikes from a safe distance. Aviation historian Sophie Laurent highlights the Mirage's adaptability, noting that the 2005 variant introduced in the 1990s incorporated new radar and fire control systems, keeping the design competitive for decades. Taiwan's purchase of 60 Mirage 2000 jets in the 1990s underscored its geopolitical significance. Despite pressure from China, France delivered the aircraft, strengthening Taiwan's air defense. Though France has replaced many Mirage jets with the Rafale, the aircraft remains vital for countries like Greece, which counters Turkish air activity, and the United Arab Emirates, which used it in Libya and Yemen. While France found success with the Mirage 2000 built solely by Dassault, an earlier French fighter came from an unlikely partnership with their historical rival across the English Channel. How did Britain and France overcome centuries of competition to build the Sepikit Jaguar, a ground attack aircraft that still flies today? The Sepikit Jaguar roars low over the landscape, a symbol of what bitter rivals can achieve when they choose to work together. Born from a partnership between Britain's BAC and France's Breguet in the late 1960s, this twin-engine ground attack aircraft marked a turning point in European defense cooperation. The companies created SEPECAT, a joint venture dedicated to developing an aircraft to replace aging fighters in both nations. What began as a training aircraft project evolved into a powerful ground attack fighter capable of delivering precise and devastating firepower. Unlike high-flying interceptors, the Jaguar was designed to operate just above treetops. Its strong landing gear handled rough airfields, and its twin engines ensured reliability even under enemy fire. The cockpit included special armor protection and a 0-0 ejection seat, capable of saving a pilot at 0 altitude and 0 airspeed. The Jaguar proved so effective that 573 aircraft were ordered worldwide. Beyond the 403 serving France and Britain, countries such as Oman, Ecuador, Nigeria, and India acquired their own fleets. While most have retired their Jaguars, India's Air Force still operates upgraded versions. India's 116 Jaguars have been modernized with advanced navigation systems, glass cockpit displays, and new weapon capabilities. These upgrades will keep them flying until the year 2034, an impressive 60-year service life. Indian Jaguars are specially equipped for maritime strike missions over the Indian Ocean, carrying advanced anti-ship missiles. The Jaguar's impact extends beyond its service. It proved that European nations could collaborate successfully on complex defense projects, laying the foundation for later partnerships such as the Tornado and Eurofighter Typhoon programs, which continue to strengthen European defense capabilities. Russia's seventh-generation fighter jet is reshaping the future of air combat. Packed with next-level technology, it is drawing concern from military powers around the globe. With stealth capabilities, advanced weaponry, and unmatched agility, the jet is changing the rules of engagement, forcing nations to rethink their defense strategies and preparedness for the battles of tomorrow. How does this cutting-edge aircraft threaten global air dominance? And what does its rise mean for the future of warfare? Join us as we explore the technology behind the game-changing jet and its potential to disrupt the balance of power in the world. The Su-57 is Russia's newest fighter jet. Built by Sukhoi, it has 2 engines and special features that make it hard to detect on radar. The Russian military started working on this plane in 1999 when they needed something more practical than their earlier design. While Sukhoi calls it the T-50 internally, it's better known as the Su-57. It is a big step forward for Russia, as it is their first military plane built to avoid detection, and they plan to use its design as a blueprint for more stealth aircraft in the future. The Su-57 can do many jobs in one plane. It can fight other aircraft in the air, hit targets on the ground, and attack ships at sea. The plane is hard to spot on radar, can turn quickly in tight spaces, and flies fast without using extra fuel. Its computers all work together, and it can carry lots of weapons. The first test plane took to the sky in 2010. However, getting the design right proved challenging. The team ran into problems with how the plane was built and how its systems worked during testing. Things got worse when the very first plane meant for actual military use crashed before it could even be handed over. In 1979, the Soviets knew they needed better fighter jets ready to fly by the 1990s. They picked Mikoyan to handle this project, and the company started working on the MiG 1.44. Sukhoi was not chosen for this project, but they did not let that stop them. In 1983, they began their research to create cutting-edge fighter technology. This work led to their test plane, the S-32, which they later called the S-37 and finally the Su-47. What made this plane special was how its wings pointed forward instead of backward. When the Soviet Union fell apart, money dried up. This meant the MiG 1.44 project kept getting pushed back. The plane didn't take its first flight until the year 2000, 9 years later than planned. The costs were just too high, so they had to cancel both the MFI and LFI projects. Despite the setbacks, Russia still wanted new fighter jets, and in 1999, the Russian Ministry of Defense started fresh with something called the PAKFA or I-21 program. Because they were struggling with money, they had to be smart about their next fighter jet. Instead of making two different planes to replace the Su-27 and MiG-29, they decided to build one plane that could do both jobs. To keep costs down, they planned to make it smaller than their previous test jets. The new plane would be bigger than a MiG-29, but smaller than a Su-27. It would also be much lighter. The old MiG test plane weighed 28.6 tons, 63,000 pounds, and the Su-47 weighed 26.8 tons, 59,000 pounds. The new design would weigh a lot less than either of those. Sukhoi and Mikoyan had very different ideas about how to handle this big fighter jet project. Mikoyan wanted all three design teams, themselves, Sukhoi, and Yakovlev, to work together as partners. The team with the best design would take the lead. But Sukhoi came with their plan. They wanted to be in charge from day one. They had already figured out who would build the engines, who would make the electronics, and which research labs would help out. Their proposal covered the whole process from start to finish. The two companies also had different ideas about what kind of plane to build. Mikoyan wanted to make a smaller, less expensive jet. Their E-721 would weigh between 16 and 17 tons, which is about 35,000 to 37,000 pounds. It would use two Klimov VK-10M engines, each producing between 10 and 11 tons of thrust. Sukhoi went the opposite way. Their T-50 would be bigger and more powerful, weighing between 22 and 23 tons. They planned to use two Lyulka Saturn AL-41F1 engines, each producing about 14.5 tons of thrust. In April 2002, Russia's Ministry of Defense picked Sukhoi over Mikoyan to lead the new fighter jet project. This wasn't just because of their good design. Sukhoi had proven themselves in the 1990s by successfully making different versions of their Su-27 jet and selling them to other countries. This success meant they had enough money to handle such a big project. The head of the Russian Air Force, Vladimir Mikhailov, said they planned to start test flights in 2007. Meanwhile, Mikoyan didn't give up. They kept working on their own smaller jet, the E-721, which they called the LMFS, meaning Light Multifunctional Frontline Aircraft in Russian, but had to pay for it themselves. When designing the Su-57, Sukhoi looked closely at America's F-22 stealth fighter. They liked some things about it, but wanted to fix what they saw as problems. The F-22 couldn't use its moving engine nozzles to help it roll side to side or turn left and right. It also didn't have much room between its engines to store weapons. And if its engine controls stopped working during extreme maneuvers, it would be hard to recover. Sukhoi didn't think the F-22 could carry enough weapons, especially since it mostly focused on air-to-air missiles. They needed their new jet to do more than that, and they designed it to fix all the problems they had envisioned. The Su-57 has a wide, smooth body that blends into its wings. Two engines sit far apart from each other. Both the tail fins and horizontal stabilizers at the back can move fully, and the tail fins angle outward to help hide from radar. The wings are shaped like triangles and have different moving parts along their edges, to help control the plane. The engine's nozzles can point in different directions, giving the pilot more control. The plane has special extensions where the wings meet the body. These push the plane's balance point forward, making it less stable but more agile. These extensions have moving parts that help control airflow and keep the plane steady, even if the engine controls stop working. To slow down in the air, the plane's wing parts move up and down, while the tail fins turn inward to catch more air. While most of the plane is made from metal, it also uses a lot of composite materials. These make up about 22 to 26% of the plane's structure and cover about 70% of its outer skin. The designers had big plans for the Su-57 from the start. They wanted it to carry lots of weapons inside the plane instead of hanging them underneath. Between its two engines, there's a large space with two main weapon bays, one behind the other. There are also smaller bays near where the wings join the body, with special triangle-shaped covers. Keeping weapons inside helps the plane in two ways. It stays stealthy because nothing is sticking out to see on the radar, and it can fly better because nothing is creating extra drag. The Su-57 can move with incredible control in any direction, thanks to three main features: its naturally unstable design, which helps with control, its advanced KSU-50 flight control computer, and its angled engine nozzles that can point the thrust. These features let pilots safely perform extreme maneuvers, like the Pugachev's Cobra, where the nose points straight up while flying forward, or the Bell maneuver where the plane seems to hang in the air. The plane can even rotate in place without losing much height. The way it's built, along with its powerful engines, lets it reach twice the speed of sound. It can even fly faster than sound without using its afterburners, cruising at 1.3 times the speed of sound. This gives it a big advantage. Its weapons can reach farther than older fighters' weapons could. With its large fuel tanks, the Su-57 can fly at supersonic speeds for more than 930 miles, which is over twice as far as the older Su-27 could go. If pilots need to fly even farther, they can extend a probe to refuel in the air. The Su-57 is the first Russian military plane built to hide from radar. Think of it like hiding from a flashlight beam. The plane uses several tricks to avoid being seen. Just like the F-22, its edges are lined up in a way that makes radar bounce away instead of back to the source. The edges of the wings and control surfaces are set at careful angles, and even the skin panels have jagged edges, all to scatter radar signals in different directions. Instead of hanging weapons on the outside where radar can spot them, the plane keeps them tucked away inside. The antennas sit below the surface of the skin rather than sticking out. The plane's surface is also covered with special materials that soak up radar waves like a sponge, making it harder for radar to get a clear picture of the aircraft. When the plane's heat-seeking sensor isn't being used, it faces backward, and its backside is coated with radar-absorbing material. The engines could show up clearly on radar, like a bright spot, so the designers had to get creative. They lined the air intake tunnels with special radar-absorbing coating and made them curve like a snake. This helps hide the front parts of the engines. For the parts people can still see, they put a slanted metal grid in front, placed about 0.7 to 1.2 times the width of the tunnel away from the engine. It's the same trick used on the Boeing FA-18EF to make the engines harder to spot on radar. The whole plane is built with much tighter measurements than older Russian fighters. Think of it like building with Lego blocks. The pieces need to fit together perfectly with no gaps to keep the plane hidden from radar. By combining its special shape and radar-absorbing coating, the Su-57 is 30 times harder to spot on radar than the older Su-27. The Su-57 uses two special engines called AL-41F1s. Think of them as super-powered versions of older Russian jet engines. When running normally, each engine can push with a force of 9 tons. These engines have a smart computer brain that controls them automatically. It's connected to the plane's flight controls, which helps the pilot steer and handle the aircraft more easily. The engines also have some clever features to help them work better. When the plane flies very fast, special ramps in the air intake adjust to help the engines breathe better. There are also metal screens that can slide into place to stop rocks or debris from getting sucked into the engines. This is helpful when the plane needs to take off from rough airfields. But these engines have had some problems. Back in 2011, at an air show in Moscow, one of the planes had to stop taking off because its engines started having trouble. Later, in 2014, the Indian Air Force said they were worried about how well these engines worked and how reliable they were. Russia is developing an improved Su-57 fighter jet. In the mid-20s, they plan to equip it with new AL-51F1 engines. These engines will be much more powerful, with 11 tons of thrust normally and 17 tons with afterburners. They'll also be more reliable, efficient, and cost less to maintain. To avoid detection, the engines will have a lower radar cross-section and give off less heat. Special materials in the front section and jagged exhaust nozzles help reduce their radar signature even further. So in a few years, the Su-57 should be stealthier, more powerful, and more dependable thanks to its cutting-edge engines. A big step up for Russia's most advanced fighter. In 2023, the engine makers started working on something different, a flat exhaust nozzle instead of the usual round one. They started testing it in late 2024. Since they had to make this new nozzle fit the existing plane, they designed it carefully so they wouldn't have to make big changes to the rest of the aircraft. Inside the Su-57's body, there are 4 hidden spaces to carry weapons. The 2 main spaces run down the middle of the plane, each about 4.4 meters long and 0.9 meters wide. 2 smaller triangle-shaped spaces sit on the sides, tucked under where the wings meet the body. To launch these weapons, the plane uses special racks made by a company called Vimple. The main compartments have 2 kinds. One type can handle weapons up to 300 kilograms, while the stronger type can handle heavier weapons up to 700 kilograms. The side compartments use a different kind of rack to hold their weapons. The plane has room for 6 missiles to shoot down other aircraft. 4 bigger ones fit in the main weapon bays in the middle of the plane, while 2 smaller ones tuck into the side bays. For fighting other planes at medium distances, it uses the KR-77M missile. This is a better version of an older missile, with new features like a smarter radar seeker in the front and an improved motor that fires twice. For close-up fights, it uses the R-74M2 missile, which follows the heat from other aircraft. They made this missile skinnier so it could fit inside the plane's weapon bays. They are also working on a completely new short-range missile called the KMD to replace it someday. When the plane needs to hit targets far away, it can use an even bigger missile called the Izdeliye 810. This is an upgraded version of another missile, made shorter so it fits better inside the plane. The plane can carry 2 of these in each main weapons bay. If needed, it can also hang the older version of this missile on the outside of the plane. The pilot looks at 2 big screens that are 38 centimeters across and about the size of a laptop screen. These screens show all the important information, just like in the Su-35S. There's also a smaller screen and a control panel with buttons. Instead of old-style dials and gauges, everything is digital. Up at eye level, there is a display that projects flight information onto a clear screen, so the pilot doesn't have to look down. It shows a view that's 30 degrees wide and 22 degrees tall. To fly the plane, the pilot uses a joystick and 2 throttle levers. All the main controls are right there on these 2 handles. The pilot can control most things without moving their hands away. The clear cover over the cockpit comes in 2 pieces. The back piece slides forward to close up. This cover has a special metal coating on it to help hide the plane from radar. The plane uses a Russian-made computer system to run everything, based on a chip called the 1890 VM8YA. One of the key goals for the Su-57 is to get all its electronics working together seamlessly. The fancy term for this is sensor fusion. When everything talks to each other, it makes the pilot's job a whole lot easier. They can see the full picture without having to juggle a bunch of different info. The plane's computer brain is called the Information Management System. It's the thing that keeps all the other systems in sync. The 2 big ones are the Sh-121 radio system and the 101KS atoll cameras and sensors. Sukhoi is handling the electronics integration in-house, which is a big job. The software has over 4 million lines of code. They're using fiber optic cables to keep everything connected. Russia's defense ministry shared some big news on Christmas Day 2020. They said the Su-57 had officially joined the Air Force. The first production planes were sent to a base in Lipetsk, in the southern military district. These initial jets will be used to figure out tactics, train crews, and put the Su-57 through its paces. They want to see how it performs day to day. The first unit set to fly the Su-57 full-time is the 23rd Guards Fighter Aviation Regiment. They are based out east, right next door to the factory. In May 2022, a couple of months into Russia's invasion of Ukraine, some Russian sources said they had sent Su-57s into the fight. The claim was that these stealth jets fired missiles at Ukrainian targets from long range, keeping well clear of Ukraine's air defenses. Then in June, the RIA Novosti news agency reported that 4 Su-57s had teamed up over Ukraine to hunt down and wipe out Ukrainian air defense systems. The Russians said this network of stealth fighters showed off the Su-57's radar-dodging tricks in a real combat situation. So if these reports are accurate, Russia's cutting-edge Su-57s have gotten a taste of combat in Ukraine. But just like the rest of the Russian Air Force, they're having to play it safe and keep their distance to avoid Ukraine's surprisingly tough air defenses. The Su-57 fighter jet is packed with cutting-edge tech that will make pilots' lives easier and help it sneak past enemy radars. The Russians are betting big on this plane, hoping it will give their Air Force a serious boost in the coming years. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.